right, so this is 11.2, 8th grade science 11.2. And the lesson talks about time. And basically, almost everything except for the week is kind of like that you look at a heavenly body in order to be able to figure it out. So, like the day, how much the earth rotates on its axis, the year, how long it takes the sun to go around, I'm sorry, the earth to go around the sun, that kind of thing. The month's usually based on the moon, that kind of stuff. So that's what we're going to talk about a little bit today. Make sure you read it, but just kind of a little preview thing deal here. That's going to bug me. Yeah. Is if you are standing anywhere on the earth, the point directly above you is called zenith. The point directly below you, I'm like through the earth all the way below you, that's called nadir. And then the meridian is the entire half that it goes all the way around through your zenith, through your nadir. So it literally has to do with it's relative to where you're standing. A transit is when an object on the celestial sphere crosses an observer's meridian. So, like we talked about before, about like, the horizon where like land meets the water if you're at the ocean, or the land if you're, out in Kansas, the mountains almost here. But that's the horizon, and the celestial sphere is kind of like what's above you and what you can see as far as space goes. And the transit would be how that celestial sphere matches up with where you're standing. So that's just like what they talk about when they talk about the celestial sphere, and like, because obviously where I'm standing, your viewpoint is going to be different than if you're standing in Australia, or if you're standing in London, or Paris, or somewhere like that. So the day, all right, the most basic unit of time is the day. Of course, the Bible talks about how God created the heavens and the earth, and the evening and the morning were the first day, or the evening and morning were the second, third, whatever day. So just a regular day has to do with the 360-degree turn that we make every single day. And so even like when we talked about planets, like their day is one rotation. And sometimes one of those planets at least, their day is longer than their year. So, we look at it a little differently here on Earth. So a sidereal day has to do with the stars. So it actually is how long it takes to spin with 360 degrees, but then we've been able to go and like view all the stars that we can view in that day. So a sidereal day is based on the stars. A solar day is based on the sun. As far as noon to noon, when the sun is like directly overhead, noon, not technically directly overhead, but you know what I'm saying. It's about overhead. That's a solar day. A mean solar day is the average, or the mean time that it takes to go from daylight till daylight again. That's some more time. Page 348, 349. We have all kinds of different types of time as far as calendars and that kind of thing. Standard solar time is based on what they call UTC, or the Coordinated Universal Time. And it's basically the average time at the prime meridian, which would be 0 degrees longitude. Runs through London, England, a few other places, obviously. Then you have summertime. We call that heaven. No, daylight savings time. That's what we call here. Daylight savings time. Some people call it summertime. And that is basically, it begins on the second Sunday in March, usually, when clocks are advanced by 1 hour. I remember one time when the president changed it, and he dealt with that or whatever. I can't remember why. But anyway, so we had it was second Sunday in March, and then the clocks advance 1 hour. I always say spring forward 1 hour, so you set your clocks forward an hour in the spring, and then you fall back an hour in the fall, and that would be the first Sunday in November. And It's supposed to, the change occur precisely at 2 a.m. and for each time zone. But, most of us, we just switch it over at midnight, or I don't know what the Apple phone does. I don't really know because I'm usually asleep. But then you have 12-hour time. That is in a 24-hour day. It's divided into two equal parts. That's what we know. It's 12 midnight to 12 noon. 12 noon to 12 midnight. And then we have AM, which is before noon, and PM, which is before midnight. And so that's called 12-hour time. That's what we are used to. Then you have 24-hour time, which is what most military branches go. We call it military time. And that would be where they go from 0 to 12, and then they start, like 1:15 would be 13:15. So they just go like the 24 hours in a day. That's not too hard to understand either. There. And then the lunar month, based upon the 29 to 30 day cycle of the moon, it's supposed to be 29 and a half days or whatever. So just depends on the month. And that's why we kind of have some days are 28, some days or some months are 28, some are 30, some are 31, and it all ends up equaling out. And then you have the solar year. It takes the time it takes the Earth to orbit the sun one time. Now remember, you have a day, and that would be rotation. It's just rotating, spinning around on its axis. And then you have revolution, and that's when it's actually revolving around the sun. So don't get rotation and revolution, rotate and revolve, mixed up. All right, so the week is not based on a heavenly body. The week is basically based on when God created the earth. Day one, evening and morning were the first day, evening and morning were the second day. And then it goes on and talks about a week or whatever, somewhere in there. It talks about he rests on the seventh day. So then that God, we talked about that being a week. And it just kind of works out. The weeks fit into the month and all of that. And then we had different calendars. You have the Julian calendar based on the length of the solar year. You have the English names for each month we get from the Julian calendar. And then we have the Gregorian calendar, and the Julian calendar was based on 365 and a quarter days, and that was in great improvement over what Roman calendars had. But it was off by about 11 minutes per year. So Pope Gregory the 13th in 1582 issued the proclamation of a new calendar, the Gregorian calendar, and it added in the leap years for those evenly divisible by 400. All right, so that's the calendar that most Western nations use, would be the Gregorian calendar. Then you have the Jewish calendar, which would have religious and secular, days that they would have in the Jewish religion, basically, their holidays and that kind of thing. And then you have the Islamic calendar, which many Muslim nations would use. It has a standard 354 days. So that's interesting. All right, the path that the sun follows is called the ecliptic. We've talked about that before. And the ecliptic intersects the celestial equator. We've talked about the celestial equator at 2 points. We call those equinox. The equinox is the fall and the spring equinox. It's when those intersect there. And sometimes spring is called vernal equinox. And fall would be autumnal equinox. And then in between those where they intersect, then the 2 points in between that are called solstices. And the solstice would be summer solstice and winter solstice. And that's midway between the two equinoxes there. That's pretty much what you have to know about that. All right, and just read about those seasons, the different zones there, seasonal weather, that kind of stuff. It's just light reading. And then do section review 11.2. Next thing I'll do is a review over 11.1 through 11.3, and then we'll go on to talk about orbits and satellites, which you should be able to get. But go back to the review lessons and review as much as you possibly can in order to get it all in your head. Have a good day.